How to test the quality of the data and complexity level of the forecast. Why normality test is done to generate a good forecast. A normality test is a statistical test used to determine whether a set of data is normally distributed or not. Normality tests are often performed as part of data analysis and modeling to assess whether the data meets the assumptions of the statistical tests and models being used. In forecasting, a normality test is typically used to assess the distribution of errors in a model. A forecast model's accuracy depends on the assumption that the errors are normally distributed, or at least approximately so. If the errors are not normally distributed, the model's accuracy may be compromised, leading to incorrect forecasts. Therefore, a normality test is done to generate a good forecast by helping to ensure that the model being used is appropriate for the data at hand. If the data does not meet the assumptions of the statistical tests and models being used, then adjustments need to be made to the model or a different model needs to be used. By conducting a normality test, we can determine if the errors are normally distributed and if the model is appropriate for the data at hand, which can improve the accuracy of the forecasts. Why PP plot analysis is done to generate a good forecast. A probability (PP) plot is a graphical technique used to assess whether the distribution of a set of data is consistent with a specified theoretical distribution, such as the normal distribution. A PP plot compares the cumulative distribution function, CDF, of the data to the CDF of the theoretical distribution. If the data is normally distributed, then the PP plot will show a straight line. In forecasting, PP plot analysis is often used to assess the goodness of fit of a statistical model to the data. If the model's assumptions are correct and the errors are normally distributed, then the PP plot will show a straight line. Deviations from a straight line indicate that the model is not a good fit for the data and adjustments may need to be made to improve the model's accuracy. Therefore, PP plot analysis is done to generate a good forecast by helping to identify whether the statistical model being used is appropriate for the data. If the PP plot shows deviations from a straight line, then adjustments need to be made to the model to improve its accuracy. By conducting a PP plot analysis, we can determine if the model is a good fit for the data at hand, which can improve the accuracy of the forecasts. How central theorem is useful to generate a good forecast. The central limit theorem, CLT, is a fundamental concept in statistics that states that as the sample size increases, the sampling distribution of the mean of the sample approaches a normal distribution regardless of the shape of the population distribution. The CLT is an important concept in forecasting because it allows us to make probabilistic statements about the accuracy of our forecasts. In forecasting, the CLT is useful in generating good forecasts in several ways. First, the CLT allows us to estimate the uncertainty in our forecasts by calculating the standard error of the mean. The standard error can be used to construct confidence intervals around the forecast, which provides a range of values within which the true value of the forecast is likely to fall. Second, the CLT allows us to use parametric statistical tests, such as t-tests and ANOVA, to compare the means of different groups or to test the significance of the relationship between variables. These tests rely on the assumption that the data is normally distributed, which is often a reasonable assumption when the sample size is large. Third, the CLT allows us to use the normal distribution to model the distribution of errors in a forecasting model. This is important because many forecasting models, such as linear regression, assume that the errors are normally distributed. By assuming a normal distribution, we can estimate the mean and standard deviation of the errors, which allows us to generate probabilistic forecasts. In summary, the central limit theorem is useful in generating good forecasts because it allows us to estimate the uncertainty in our forecasts, use parametric statistical tests, and model the distribution of errors in forecasting models.